And I will introduce Agnel and Ben, and we'll let them introduce the talk.
Good afternoon, and welcome to this talk on Vanguard's data perimeter journey. My name is Ben Joyce. I am a IAM cloud leader with Vanguard, and I'm joined by Agnel Amodia, who's our tech lead, who has been leading and driving our data perimeter program. In today's session, we will look at what went into defining our boundaries, our implementation plans, the strategies that we use for planning and collaborating with development teams and other centralized teams. We'll also look at some key challenges we had to overcome in terms of AWS limitations and such. And we'll take some questions in the end. First, a quick look at Vanguard. Vanguard is one of the most respected investment management companies in the world, offering a broad selection of investments, advice, retirement services, and insights to individual investors, institutions, and financial professionals. We adhere to a very simple core purpose: to take a stand for all investors, to treat them fairly, and to give them the best chance for investment success. We just recently celebrated our 50th anniversary. We are headquartered in Malvern, Pennsylvania. We have more than 16 global locations spread out across North America, Europe, and APAC. Currently, we cater to more than 50 million investors, supported by our 20,000 awesome crew members. So that gives a sense of the scale, the responsibility that we are operating with. So it isn't just about protecting our workloads. It's more about preserving the trust and confidence of millions of people who trust Vanguard to secure their financial future every day. A little bit on the lay of the land in terms of the scale and complexity we are operating with. Currently, more than 80% of our workloads are in the cloud, most of it in the AWS cloud. At a high level, our AWS org is segmented by environment and business domains. So what that means is our AWS OUs are logically separated by production, non-production, and specific business domains. And our SCPs are applied to these LOB-specific OUs, and they're custom-built based on the risk profile and the governance needs for each one of these LOB OUs. And from a scale perspective, we're talking about 500 plus AWS accounts, more than 10,000 human identities, and 16,000 application identities spread across 700 plus VPCs. And in some of our busiest AWS accounts, we're talking about 1,000 S3 buckets, 5,000 AWS roles, and more than 10,000 policies in a single account. Moving on. So there is also complexity added in terms of how our policies are managed by the different teams that manage those policies. We primarily have three stakeholder groups. Number one, the centralized network and infrastructure team. They own the VPC endpoint policies. That helps them manage network access, that helps them to bootstrap AWS infrastructure. And then comes the centralized cloud IAM team that Agnel and I are part of. We manage the SCPs, RCPs, and permission boundaries. So we make sure that we enforce the security invariants and org-wide controls, preventive pipeline checks, so that way we can enable new AWS services in a very secure and scalable way. And both of these centralized teams are what help us provide a more decentralized approach to our development teams so that they can focus on just granting access to their applications so that they work, and they use resource-based policies and permission policies to make that happen. And to add to that, not all applications behave the same. Production applications have to access non-prod data, and some of our applications need to send data to third-party applications, third-party vendors for regulatory purposes. And some of our CSPM tools have to scan the entire AWS org for security findings. So we're talking about not just layering controls, we're talking about having to thread a needle through existing independently managed controls. And moving on to how we built our controls or our control objectives. When we break down AWS to its core pillars, its identities, resources, and networks, and that's precisely where we applied our controls. We used RCPs to make sure that only trusted identities can access our resources. We enforce VPC endpoint policies to ensure that access came only from our approved networks, such as our internal VPCs and our corporate CIDR ranges. By aligning each of these controls to a specific component, identity, resource, and network, we were able to build a perimeter that's clear, scalable, and secure by design. And it's very important also to define our boundaries before we embark on this implementation journey. For each org, it could be different. For us, it's pretty straightforward, but it is important to kind of go with that quickly as well. For resource perimeter, what that meant is non-prod IAM principals cannot access prod resources and vice versa. And this boundary also prevents any of our org's IAM principals from having access to resources that do not belong to our organization. For network perimeter, it meant that access to our resources will be allowed only when requests originate from our trusted networks like our VPCs and our corporate CIDR ranges. Anything coming from the public internet, even if it's through a principal, even if it's through our corporate principal, is blocked by default. And lastly, for identity perimeter, only trusted identities from within our organization can access our AWS resources. Anything from outside Vanguard's AWS org is blocked by default. And of course, there is exception handling, but this is the boundary that we defined. Over to Agnel for going over our implementation, the exception handling, and the challenges that we had to overcome.
Good afternoon, everyone. I am Agnel Amodia, Technical Lead at Vanguard Group. So when we started implementing our defined boundaries using policies, one big question was whether to apply these policies at account level or OU level. OU level policies are easier to manage at first, but it becomes a problem when you need fine-tuned exceptions for specific teams or accounts. So we chose to apply these policies, RCPs and SCPs, at account level, which gave us more control and flexibility. We also kept the OU layer clean so it can be used later on for broader security invariant controls or service enablement controls enforcements. So once the key decisions were made, such as defining the defining the boundary for the organization and applying them at the account level, the next big thing was implementing them using policies. But here is the challenge. There is no dry run mode for this policy, which means once the policy is applied, once the policy is deployed, it is immediately effective, and it can break the applications without even warning. So we relied on a CloudTrail logs to identify how my applications are behaving today and predict what it can break tomorrow. So for resource perimeter, we built Python scripts to look into the CloudTrail events to identify user identity.account ID did not match with a recipient account ID field for particular IAM user or role. And if it is identified for, say, let's say, from development environment, if an IAM user or role is trying to access resources in a production environment, we flagged it for a violation. So in a nutshell, if the resource is not part of our organization, we flagged it for a violation. Similarly, for network perimeter, we scanned all API activities to check whether a request made by an IAM user or IAM role is coming from trusted networks using a source IP address. Then we compared this source IP address with an internal network VPCs and corporate CIDR IP addresses, and if the request is identified coming from outside our organization, we flagged it for violation. So one of the key important decisions we made while rolling out network perimeter controls was not to roll out controls for all identities. First, focus on rolling out controls for network perimeters only on privileged identities such as human identities, user identities, application identities, and EC2 instance roles. And before implementing network perimeter controls for Lambda functions, we built a detective controls to enforce developers to bring their Lambda functions within a VPC, and that gave enough time to developers without breaking anything. Similarly, for identity perimeter, we checked whether if any application outside from our organization is trying to access our resources, we considered that resources as an external principal and flagged it for violation. In all cases, whether it's a resource perimeter, network perimeter, or identity perimeter, we identified the script we built, identified all risky IAM identities and risky resources. And this report helped us reach out to the development teams with a clear message that, hey, here are the resources that may be impacted if we enable RCPs and SCPs tomorrow. And this visibility was really crucial for us because of the smoother rollout and balancing between the business continuity and security without taking down any critical applications. One of the challenges we faced in a data gathering from CloudTrail was incomplete visibility. Not all API activities were logged in a CloudTrail because of the business reasons or service limitations. So if, for an example, let's say at S3 GET object calls were not logged in the CloudTrail, we could not see which IAM users or roles are trying to access resources outside our organization. So, which means we risk missing critical patterns, and if we rolled out controls blindly, that could have broken the production applications. So we took a different approach here. We involved developers. We make sure we spread awareness about data perimeter program across the organization and ask the development team to review their IAM permission policy and resource-based policies. So here are the few conditions we used while implementing RCP and SCPs. I think pretty much everybody is familiar with this conditions key, so we are not gonna go too much detail into it. One of the challenges we faced while rolling out network perimeter controls was managing VPC IDs and corporate CIDR, corporate IP addresses at scale. At first, we hard-coded all these values into the SCP and RCPs, but as more VPC IDs are added, policy size grew and we hit AWS limits. And in addition, if new VPC IDs are created because of the nature of we have hard-coded all these values, we have to manually update each and every policy across the organization, which is not a practical solution when you are dealing with hundreds of AWS accounts like we are at Vanguard. So the better solution, we deployed a Lambda function that runs in each and every AWS account. And this Lambda function dynamically fetches all VPC ID and corporate CIDR blocks and feeds them into the CloudFormation template, so we didn't have to hard code anything. But this is not an ideal solution. What if the Lambda function fails? If the Lambda function fails, policy deployment fails too. And on top of that, adding every new VPC ID is added, we have to redeploy everything. So the better solution, if AWS has provided a global condition key such as a VPC or ID that could tell us whether the request is made by an IAM user or role is coming from any VPC within my organization, this whole process would be much more simpler, faster, and reliable. While designing identity parameter using resource control policies, we used the principal org path condition key to allow access from trusted organizations' identities, and for exceptions, we use resource tag condition key to allow access from external partners at the resource level. But we hit a challenge. Resource tag is not supported on S3 bucket. It only works on individual objects, and taggings of millions of objects for thousands of S3 bucket wasn't just a practical solution for us. So we took a coarse-grained approach. Using a principal account condition key, we built our RCP policies. But this is not, again, an ideal solution. If AWS could provide a resource tag condition key which can support the S3, which is available for S3 buckets, we can freely design the fine-grained access controls for S3 buckets. So after rolling out controls for using SCP and RCP wasn't just an end state for us. We have to make sure everything is working as expected once the controls are rolled out. So first, we ask developers to post-certify their applications, to test their applications, to catch any access denied errors. And we built a CloudTrail dashboards to identify or to monitor any large spikes in access issues. This gives us the real-time visibility into how our policies are behaving. If there is any large spike in access issue, which means something is wrong with our policy, we rolled it back, we investigate it, fix it before reapplying it. And there is only one IAM role or user was affected, we directly work with the client or a developer to add necessary exception tag to the respective resources. This is a really important topic regarding the exception. To manage exceptions properly, we did not rely on a manual tracking. Instead, we built it into our CI/CD pipeline. For an example, a developer includes external access into their IAM permission policy or resource-based policies. The CI/CD build fails. And to continue, they must log a risk into the risk management system. Once it is approved, they can go ahead and apply the data perimeter tag to the respective resources. On top of that, we run regular queries to identify all IAM users or roles or resources with a data perimeter tag which has no documented exception. So this report helped us reach out to the development teams to ensure that the exceptions are properly granted, approved, and tracked. So here are the few key takeaways we learned from our journey. Start with small. Do not roll out everything at once. Define the trust boundary for your organization at first ahead of time. Get the developers buy-in first. The more your developers understand data perimeter goals, the smoother your rollout will be. Focus first on identities that carries the most risk. That's where you are going to get the most value out of it. And always be mindful about SCP and RCP size limit and design with scale in mind. Always use a tag-based approach. If it is not supported, fall back to the account level exception. And lastly, if something is not supported by AWS, a feature is not supported by AWS, don't wait. Engineer your way forward. We did it at Vanguard, and you can too. Thank you so much, everyone.
Questions from anyone?
Amazing talk. Quick question. How do you handle net new AWS accounts that get onboarded to your organization?
You're saying the number of AWS accounts?
No, net new AWS accounts that get created?
I did not get it.
Like new AWS accounts that are created?
The frequency with which the new AWS accounts are created.
Yeah, like how do you go about implementing all these controls on new accounts? Is that automated or how does that look like?
It's not automated. Someone has to redeploy SCP policies and RCP policies manually. So let's say for an example, if one AWS account is created, the SCP and RCP policies are not deployed automatically. Someone has to still, there is a manual process that someone has to click a button to deploy this SCP and RCPs.
Okay, thank you.
Yeah.
Hey, I was wondering, how did you guys engage the developers in your organization? Were you manually reaching out, or did you have a tool helping you, or because you said you had 20,000 employees? So.
Yeah, excellent question, because couple of mediums we used reaching out to the developers. One is we had a program going on in our organization. That program helped us to reach out to each and every line of business of different teams in the organization. That's one way. Another way is we hosted office hours to spread awareness about data pyramid program across the organization for a month and more than that. Another way to reach out to the development team is through email communications. We identify all risky IAM roles, users, the application that were impacted from the CloudTrail. We gather all these inventories and send it out to the development team through emails. So those are the three key mediums we used to reach out to the developers.
Hi, great talk. I'm curious, how did you implement that CI/CD checks?
Yeah, so we use CSPM tool to write all the codes. So whenever a developer pushes any code change, the CI/CD tool, the CSPM tool checks behind the scenes whether the policy contains any kind of a violation. For an example, like external AWS account, if it is there, then the CI/CD builds fails. And to fix that build, developer needs to document the necessary risk. Once the risk is approved, the CI/CD pipeline will check that the risk is already approved, then CI/CD pipeline will be successful. And after that, developer can go ahead and add the necessary data parameter tag on the respective resource.
We'll take one more.
What does the process of logging a new risk into the risk management system look like? Did your team need to approve all of those risks? And if not, who does?
Yeah, so it depends on the organization's ownership and responsibility. We are part of the IAM cloud team, and we owns all permission boundaries, IAM permissions. So if the IAM permission policy violation occurs, we are the one who review the risk and approve the risk. But let's say if there is an example, there is a infrastructure control violations, that goes to a different team.
Thanks, everyone. I know there's some questions in the Slack as well, so please, I encourage everyone to pick up the conversation there if there's any more questions. But for now, thanks for talk, and let's give them a round of applause.